The Life Cycle of Stars
by Bella and Veronica.
Nebulas. A nebula is a cloud of gas and dust in outer space. Some nebulas are visible from the night sky as bright patches of light. There are 4 types of nebulas: emission, reflection, dark, and planetary. Emission nebulas emit a light of different wavelengths. Reflection nebulas reflect the light of nearby stars. Dark nebulas are so dense that they obscure any visible light, and planetary nebulas are the result of gas and dust from dying stars. Famous nebula, Pillars of Life, is an emission nebula. Among the types are 4 different classes, all dependent on shape: elliptical, spiral, irregular, and diffused. Most nebulas are diffuse, meaning they have no distinct shape. Nebulas are mostly made of hydrogen and helium, which are some of the most stable elements. Nebulas can act as a sort of record keeper of the universe, since depending on their location, size, and age, they can reveal a lot about the composition and evolution of space. Nebulas are a result of accretion, just like everything else in our universe: stars, planets, etc. Accretion is the gathering of molecules through growing forces of gravity, which form larger bodies like protostars. Accretion is able to happen because
Magnetohydrodynamics,
which pushes and pulls plasma. Without accretion disks, nothing we see in space exists because nothing will be pulled together with a strong enough force. The larger bodies caused by accretion are called protostars. Protostars are stars in which the core is not hot enough for fusion to take place. Protostars are a result of accretion forming a mass of dust and gas around the protostar. These forms can be called gas giants. A protostar becomes a main sequence star when the core reaches 10 million Kelvin, in which the beginning temp for nuclear fusion takes place. Nuclear fusion is a reaction of hydrogen filling to helium due to accretion and being pulled together by gravity. The duration of the fusion depends on the amount of material in the reaction. Nuclear fusion is used as fuels for all stars in the universe. Nuclear fusion is commonly mistook for nuclear fission, which is a separation of molecules. Nuclear fission can be utilized in spacecraft to fuel and propel ships, so fusion is the fuel for stars and fission is the fuel for ships. Like fusion, however, fission does not emit any greenhouse gases. 90% of stars in the universe are main sequence stars. Main sequence stars are the standard stars that are powered by nuclear fusion. The duration of the star's life depends on how much hydrogen and helium is reacting with each other. All main sequence stars will burn for millions of years and appear to be unchanging. Eventually, the main sequence star will run out of hydrogen, in which the star will begin to collapse in on itself. 3 main sequence stars in our universe are Sirius, Alpha Centauri A, and our Sun. A red giant will form once the main sequence star runs out of fuel and collapses in on itself. During the collapse, the core begins to take on a lot of pressure, and the nuclear fusions begin taking place on the outer layers, which causes the red giant to become unstable and expand to a much bigger and hotter form. After the red giant phase, there are 2 other routes that a star could take.
If the star is smaller than 8 solar masses, then it becomes a white dwarf. White dwarfs are essentially the dead core of a star. At this point, no more fusions are taking place in the core of the star. White dwarfs occur when red giants reach a mass that is so large that they implode on themselves. The force of this reaction causes millions of explosions deep within the core. This event causes an insane amount of energy to be released, causing the star to burn white hot. These stars are incredibly dense, and their size can range from the size of Earth to the size of our Sun. White dwarfs burn white hot from millions to billions of years, but eventually they do have to cool off. This is when a brown dwarf occurs. The energy that was formed from when the white dwarf occurred is now eventually going to die out. The color shifts to brown, and it becomes what we know as a brown dwarf. If the star is more than 8 solar masses, then a red supergiant forms. In this stage, iron fusion occurs. The helium in the core is being exhausted, and the star is beginning to burn carbon. In time, the core will be completely made out of iron. These stars usually burn from about 3,500 to 4,500 Kelvin. The next step in a star's life after the red supergiant is a supernova. Supernovas occur when the star suddenly gets so massive that the star collapses in on itself due to gravity. All of the particles collide with such a force that its explosion sends dust from the imploded star outwards into space in all directions. The propelled debris will eventually find other space dust and form a new star. What happens after this awesome explosion depends on the star's initial mass. If the mass is less than 40 solar masses, then a neutron star occurs. A neutron star is essentially the core left behind after a supernova. During this stage, something called neutron degeneracy pressure occurs. When this happens, neutrons left over from a supernova cannot possibly be more packed together, so it results in a very, very, very dense core. There's estimated to be about 1 billion neutron stars in the Milky Way galaxy. If the star's mass is greater than 40 solar masses, then a black hole is formed. A black hole is a region of space-time where gravity is so strong that not even light can escape it. These black holes can grow by absorbing mass from its surroundings, which is terrifying.
So why is it so important to know where stars come from? Well, I think it's important to know how our universe works, considering we're living in it, and quite frankly, it's very interesting to know about.
Yeah, I think it can really like help like put things into perspective, because like this whole class has sent me into like an entire like spiral of like being aware of like everything. So I don't know. I think it's cool.
Mm-hmm.
Thank you for watching our video presentation on the life of a stars. Please give us an A.